All right, so what we're looking at right now is how to read a contour map. All right. Now, on contour maps, frequently they'll tell you what the contour interval is. That's how much the lines are going by. But sometimes they won't, and you're expected to be able to figure it out by looking at the map. Now, how you're able to do that is usually every fifth contour line is a little bit darker and it's labeled with the value. So like this line right here is the 100 meter index contour. And then I look up here, here's a 200 meter index contour. Now from that, I should be able to figure out what the lines are going by. And you can kind of do it by trial and error. So I can kind of figure out, oh, let's see if it's going by 10. So 100, 110, 120, 130, 140, 200. No, it doesn't work. So then I try by 20, 100, 120, 140, 160, 180, 200. 20s work. So my contour interval is 20. Okay. Usually it's going to be like 5 or 10 or 20 or 50, something like that. It's not going to be anything like 22 or 37 usually. All right, next. So here I have a hill, and I can tell where the hill is the steepest and where it's the flattest by looking at the contour lines. How I can tell where it is the steepest is where the lines are closest together. So right here, the lines are very close together. That means the land is very steep. All right, so it has the biggest gradient right there. So now I want to describe that side of the hill. So what I want to do is I want to look for my compass here to tell me what direction is north on the map. Now normally north is up, south is down, east is that way, west is that way, but not always. Sometimes this might be pointed sideways or something like that. But this is a traditional one where north is up. So it would be north, this side would be east. So it's the east side has the steepest side because the lines are closest together. All right, the flattest side, or in other words, it's saying which one has the smallest gradient or lowest gradient, that's going to be where the lines are farthest apart. So what I'll notice is that over here, the lines are very far apart. That means it is very flat. So that side would be the west side. Highest value of x. All right, so I know I'm going by 20s. So there's 100, 120, 140, 160, 180, 200, 220. So 220 is the height of my top contour line. My question is, what's the highest value x could be, or what's the highest value the top of that hill could be? Well, my last contour line is 220, so I know it is more than 220, right? Because when I draw a 220 line, everything on one side of it has to be less than 220. Everything on the other side of it has to be greater than 220. So I know the top of the hill is greater than 220. But what I also know is that it can't be 240 because there's no 240 lines drawn. So if there are any values at 240, there would be a 240 line. So the top of that right there is greater than 220, but less than 240. So it could be anywhere from like 221 to 239. But if your question was, what is the highest it could be? In this case, it would be 239. Right. Another thing you can find by looking at contour maps is you can figure out what direction streams are going. Now, wherever there's a stream on a contour map, it's going to carve out little V's in the contours. And the stream goes right down the little V's. So you can tell where the stream is by looking at the V's, because sometimes there might not be a blue line there. Like if the stream only flows like a few days a year, they might not put a blue line on the map, even though there's like a little valley there. But anyways, so the little V's show you where a stream valley is, but it also tells you what direction the stream is flowing. Now, the little V's do not point in the direction the stream is going. Rather, the little V's point upstream. So if the little V's in the stream are pointing this way, that means the water is flowing that way. So this stream is flowing that way, which again, that way is to the west. All right. Next, what has the same elevation as A? All right, well, any 2 points that are on the same contour line are going to have the same elevation. So A and B are on 2 different lines. They're not the same. A and C are on two different lines, but if I look, A and D are on the same line, therefore they're going to have the same elevation. All right. Now another thing you could do with maps like this is you're quite frequently used to calculate gradient. So let's say I want to find the gradient from A to B. Right? So the formula for gradient, again, is change in field value on top over distance in the bottom. So A has a value of 100. We said the contour interval is 20, so that's 100, 120, 140. So B is on the 140 line. So if I want to calculate the gradient between A and B, I'm going to do 140 minus 100 on top. Let's see how much of a distance there is between those two. Now, next thing I need, number on the bottom, is how far apart they are. And I can do that by using a scale. So your map should have a scale, which is right there. So I come over here, I mark off A and B. I go to my scale, and they work out to be 6 kilometers apart. So 6 kilometers goes on the bottom. So now I can simplify that. 140 minus 100, there's a 40 meter change over 6 kilometers. I pull out my calculator. 40 divided by 6 works out to be 6.7 meters per kilometer. All right. So that's the gradient between A and B. All right. Now, gradient between C and D. All right. Well, if I look, C is on the 200 line. D is on the 100 line. Next, I want to measure the distance between them. Go to my scale. It's about 2 kilometers apart. So 2 kilometers goes in the bottom. 200 minus 100 is a 100 meter difference over 2 kilometers. 100 divided by 2 is 50 meters per kilometer. Okay. So what you should notice from that, again, is where the lines are far apart, like they are between A and B, I have smaller value of gradient. Where the lines are closer together, like they are between C and D, I have a bigger value for gradient. In other words, it's steeper there. All right. A few other things I want to show you on contour maps. So we'll take a little trip. All right, so let's say this one here, all right? So we have an island here because it's in the middle of the ocean, and I want to figure out what my contour interval is. Now, on this one, I only see one line that's labeled. I only have a 50 line, because on the other map, I had 2 different labeled lines, so I was able to figure out what the lines are going by. In this case, I only have one of them that are labeled. But in this case, I could still figure out what the contour interval is. If you remember what that 50 means. That 50 means 50 meters above sea level. So in this map here, I'm telling you that this right here is the ocean, right? So this, the ocean, is sea level, and that's 50 meters above sea level. So the shoreline of the ocean is going to be right at sea level. So even though it's not labeled as such, if this is the ocean, the shoreline is basically the same thing as a 0 contour line. So if this is the shoreline, if that's 0 and that's 50, then I'd be going 10, 20, 30, 40, 50. My contour interval is 10. Right? Next, the stream direction. Right? My little V's in the streams are pointing this way. That means the water's flowing that way. So I look for my compass, top's north. So if it's going that way, the water is going south. Right? Highest elevation for point X. All right, so I'm going 0, 10, 20, 30, 40, 50, that's 60. So the top of that has to be greater than 60, but I know it's not 70 because there's no 70 line drawn. So if the top of that's greater than 60 but less than 70, it could be anywhere from 61 to 69, but it says what's the highest elevation for X? So that'd be 69 for that. All right, now for these guys. All right. Let's say I have a map like this. All right, so this is a map that has a hill on it. All right, like a side view of the hill might look like that. So that's the highest part of the hill right there. Now, instead of a regular hill, let's say we had a volcano. All right, so with a volcano, you're going up, 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 and then there's a hole on top of it like that. All right, to show that you have a depression or to show that you have a hole, we use a special kind of isoline called a depression contour. So that's a depression contour right there. So it's not a regular line. It has these little, kind of look like hairs on them. They're called hatch marks on them. It kind of looks like that. All right, so that signifies that I'm counting down, not up. Now, let's say I want to figure out what the elevation of point F is on that. All right, so people are like, well, there's 10, there's 20, there's 30. At first glance, you would think, okay, so if my last contour line was 30 and I'm counting down, you might think that F would be 20, but it's not. All right, the main rule for depression contours is that your first depression contour always has the same value as your last regular contour. Your first depression contour always has the same value as your last regular contour. And the reason being is if that's 10, 20, 30, and this is a 30 line, that means like this area, like right there, has a value of like 35 or something like that. So it went 10, 20, 30, it went up to maybe like 35 or so. And now it's going back down into the hip, down in the hole. But if I'm going back down, my first interval of 10 is going to be 30 again. So it goes 10, 20, 30. It goes up a little bit more than 30, like 35. Now I'm going down into a hole. So my first depression contour is actually going to be the same value as my last regular contour, right? With this area in between here being maybe like 35 or 33 or something like that. And then the next one like right there, then that would be 20 and so forth. But your first depression contour always has the same value as your last regular contour. Right? So the elevation of point F would be 30. All right, so those are the main things that you need to know about how to read a contour map.